Last time I ended my video talking about private clouds, and now I want to concentrate on one specific architecture or technology, how you can create your own efficient, modern private cloud. By the way, if you haven't seen the video, the previous video of mine, I will leave a link in the description field, and I highly suggest that you take a look at that video before and then come back to this video. Okay, so let me just once again take a step back and draw the traditional basic data center, how we have been architecting and constructing data centers already for decades. And as we remember from the previous video, we have three tiers, if you will. The first one would be networking. Then we have servers, and a third one would be storage. We have to have these three tiers in any kind of IT environment that we are dealing with. So we have storage devices here, a couple of them, of course, for redundancy. We need to have a couple of SAN switches to connect our storage devices to servers. We probably have some hypervisor software there to cluster the servers, and on top of everything we have networking devices to connect our servers to outside world. This is something that we call a three-tier siloed architecture. Three-tier, obviously, because we have three tiers: networking, servers, and storage. And then siloed, because all of these tiers are quite independent of each other. When you want to operate something, when you want to manage something, it's always done at that tier level. If you want to do it in storage, you only operate and manage storage. If you want to do something in networking, you do something in networking. And the downside of it is that if you are doing an upgrade in storage environment, although it's managed and maintained independent of every other tier, you still have to communicate with the server guys for them to know that there's a new storage device and all the zoning stuff and all those things are in order. So that makes it a bit complicated to manage. And to make it a bit more complicated, let's add a couple of things into the picture. You should never forget the importance of a backup device. So there's always some kind of backup device connected to the storage area network. Also, if and when we are talking about the real world implementations, no real enterprise is ever trusting only one data center. Last time we were talking about redundancy on a component hardware level, but we also want to be sure that if something happens to this one data center, our data is not lost and our business continues normally, at least as close to normal as possible. So that's why we want to have more than one data centers. Let's add our site A here. So this would be our primary data center. This is our site A. So that would be our secondary data center, just as a backup in case something happens in primary site. Now, we have to do some kind of replication between the sites here, some kind of bidirectional replication in order for us to be sure that all the same data is available in the site B as in site A. This can be quite a tremendous task, and there are various different technologies how to achieve this. We can use, for example, something we call WAN optimization, which is basically just compressing the data coming from site A going to the site B. Looking at this picture already now, it's complicated. We have lots and lots of different components in site A, site B, replication happening here and there, siloed infrastructure and everything like that. But the complexity doesn't stop there. It's not complex only from infrastructure hardware point of view. We have also many different kinds of user interfaces that we have to use to manage this whole environment. Hypervisor environment is probably managed with one type of user interface. We have another user interface for managing servers. Probably we have a few of them there. Storage area network is managed with different user interface. We have a fifth user interface to manage storage devices. Backups are managed with different user interface, most probably. And then we still need one user interface to manage the whole WAN optimization. So what I want to do now is to get rid of as many hardware components from this picture as possible without sacrificing any of the benefits that I have in this environment. The second thing I want to do is to get rid of most of these user interfaces. So what we can do is we collapse these two tiers completely. So we get rid of independent individual servers. We don't have to worry about storage devices, SAN switches, and backup devices. Instead, we have just one x86 server. x86 meaning just an industry standard server running Xeons and so on and so on. What we have there inside is a powerful CPU processor that's running all our virtual machines, all the workloads there. Then what we have is lots of storage capacity. It has lots of disks installed in it. Of course, in enterprise environments, we are not trusting any individual component, so we have to have two of these devices here. Then what we do is we connect them together, and that's it. Here we have exactly the two tiers, server and storage tiers, inside these server appliances, as we call them. They're just hidden inside the appliances, and they are not separate devices. So this would be our site A. We need to do still the same for site B here. We still have the backup site. And the best hyperconvergence solutions out there nowadays are directly communicating with sites without the need of any special WAN optimization or anything. They use sophisticated file systems to make sure that all the data is compressed and optimized so that they can be sent over vast distances. This was our site A, and this is now our site B. So now we have already vastly simplified the left-hand side picture infrastructure to the right-hand side picture. The second goal I had was to make the management as easy as possible. All of these boxes, these special server appliances, are belonging in the same federation, as we call it. And one federation is managed with one single user interface. So all we need is one user interface to manage everything. This is the beauty of hyperconvergence. We are getting rid of the infrastructure complexity, and we are introducing new simple ways of constructing the data center managed with the one 25% off. Now, for obvious reasons, hyperconvergence is the fastest growing individual technology within the data center industry at the moment. Everybody wants to be in the industry, everybody wants to be inventing this and that with the hyperconvergence idea. Because people love simplicity, people love efficiency, and that's what hyperconverged infrastructure brings to the table. I would like to give you a couple of tips how you can choose the best hyperconvergence solutions for your needs when you are going through the options and selection. And actually, there are only two. The first one I want to emphasize is as hyperconverged as possible. Now, what do I mean by that? So, if you want to call yourself a hyperconverged solution, the minimum, the bare minimum requirement is to collapse these two tiers. You have to get rid of separate server tier and separate storage tier. That's the bare minimum. However, the best hyperconverged solutions don't stop there, but they go the extra mile or two to converge as much infrastructure as possible into these tiny little appliances. So what we can do is to convert obviously server and storage, but also, for example, backup and WAN optimization. So keeping in mind that there are different kinds of hyperconverged solutions out there. Some do the bare minimum, some of them go the extra mile, and some of them go 2 extra miles. Most typically, hyperconverged solutions can consolidate the infrastructure with a ratio of, let's say, 4 or 5 to 1. So let's say you had 5 racks of traditional infrastructure before, and when you move to hyperconvergence, you manage only with 1 rack. That's pretty cool. But some of the best solutions can reach as high as 10 to 1 hardware consolidation ratios. The other aspect of this is the data reduction. The most sophisticated hyperconverged solutions out there, they can reach up to 50 to 1 data reduction. What this means is that if you have 50 terabytes of data, only 1 terabyte is actually written on the disks. So that's number one. Number two, make sure that your solution is a true appliance. What I mean by this, true appliance, is that if we take a look what this hyperconvergence node, this appliance actually is. So HCI is x86 hardware plus HCI software, hyperconverged infrastructure software. So we have a common off-the-shelf industry standard server with special software. Now, once again, there are many different approaches to hyperconvergence in the market at the moment. There are companies who are only concentrating on this part of the equation. So they develop their software, then they install it on somebody else's hardware. Quoting one of the true living legends of the IT world, Alan Kay, who is, by the way, the grandfather of modern user interfaces as we know them, he famously said that people who are really serious about software should make their own hardware. And there's a lot of wisdom in this. I'm not saying that you cannot get anything good out of just creating your own software and using somebody else's hardware. Of course you can. There are plenty of examples in the market of brilliant solutions that are using software from one company and then hardware from another company. However, those companies who are making their own software running on their own hardware are very highly successful because they can optimize everything. They can optimize their software to run on their hardware, and they can optimize their hardware to run their software. From end customer point of view, it's day and night difference in having to have support from one company when it comes to software and support from another company if there's a hardware failure. We want our hyperconvergence solution to be true appliance. We want software and hardware to work in perfect harmony, in sync with